हरिः कर्ता।
Now let's look into the second way of doing the organizing the data. That's our data categorization. So what's a data categorization? How this data categorization makes our data organized? Let's look into that. So data categorization involves grouping data into categories or classes based on a particular attribute or a variable. So this can be achieved using conditional statements or functions in Python. So before we get into the examples, I just want to reiterate what does a data categorization mean. So data categorization involves grouping data into categories or classes based on a particular attribute or variable. So let's take this example on the screen. You have device level installations. So in USA you have done some iOS installation, and in Spain some, and iOS from ad, and then from email Android, and in Korea you have done some Android installations. So these are the device level installations at USA, Spain, Korea, and from ad, from email. So these are the things that you have done. So now I want to aggregate this data based on two parameters. One, iOS, based on the iOS number of installations aggregated to iOS and Android. If you see that iOS 1, 2, 3, 4, 5, 6, total 6 iOS installations, and 1, 2, 3 Android installations. This is what we called as uh, a data categorization, or grouping data into categories or classes based on a particular attribute or variable. It could be sales data, aggregating the sales data based on a region, aggregating the sales data based on the state, aggregating the sales data based on the product, aggregating the sales data based on the country, aggregating the product number of products sold based on the region, or based on the state, or based on the channel that you have, based on the, or based on your outlets. So this is what is called data categorization. So now let's look into some of the examples in Python. So data categorization. Yep. So first example for us here is, let's take an example of categorizing data into bins or categories. Either sometimes you call bins or categories. So example of categorizing data into bins or categories. So ages is equals to 22, 34, 45, 56, 67, 78, 89, 90, 95, and 100. More than that we can't go now. Okay. So now let me put into age bins. Age bins is an empty list. Now we'll use a simple for loop. For keyword, then age is our target variable or iterative variable, whichever you can call it, and in is membership operator. Then ages is our sequence. Then colon. It will make you to allow it get into the block under the for loop. The top one is header. Under this we'll write the block, 1 level indentation block. So the first one, we'll make it into the first bin. So let me type that. If age, sorry, if age, which is iterative variable, less than 30, then age bins append, of course it's a sequence, append and as a 20s. Okay, the age as a 20s. Then elif age is less than 40, then as usual age bins again append as 30s. Next, elif age less than 50, age bins dot append its 40s. And finally, else age bins append, will put it into 50s plus. That's it. Our categorization of age data with labels is ready. So now let me close this loop and come back to the 0 level indentation, or we can call it as a top level, and then print age bins and give the age bin sequence. Invalid syntax, yep, comma is missing. Age bins, sorry, age bins, okay, got it. This is, the colon should be inside. Yep, that's it. So 20s, 30s, 40s, 50 plus, and here is that. This is how you basically categorize the data that you have. This is the way of categorizing the data with the labels. So this is using Python, and we will do examples using pandas. Okay, a few more examples using pandas. So with pandas, example 1, categorizing data using a cut function or cut method. Cut method. So let's take a data frame. Let's create a data frame. Df is equals to pd dot data frame, and inside that again a dictionary with two key value pairs. The first one is age, and then it consists of a list of values. That's 25, 30, and then we'll go for the 22, and 35 would be fine. Then finally 28. That's our first key value pair, and the next one is income. And income, again a sequence. This time I'll go for 50,000 monthly, and 60,000 again monthly, and 55,000 monthly, and finally 70,000 and 65,000. That's it. Our data frame is ready. If you want to see, I'm going to show you df, and this is what is our data frame. Oh, sorry, let me execute. Yep, this is what is our data frame, and age and income. Now, so let's create a bins. Let's define bins and labels for categorization. So bins is equals to 20 to 20, 30 and 40 and 50. So these are our bins, and labels is equal to, so first label 20 to 29, second label 30 to 39, I'm sorry, 30 to 39, then the third label it's 40 to 49. Okay, that's it. So the age between 20 to the members whose age is between 20 to 30 comes under label 20 to 39, and 30 to 40 will comes under 30 to 39 label, and 40 to 50 will come under 40 to 49 label. So always remember, your bins would be 4 and then your labels would be 3. If bins is n, labels would be n minus 1. So now let's add this new column, a new age group column into our data frame. So add a new column, age group to data frame based on the age column values. Okay, so data frame and age group, this is what I'm gonna add, and pd cut method, cut method I'm gonna use here, and then obviously, so df values are from age it has to take, and bins is equals to bins, and labels is equals to labels, and execute. So this is our df, this was the df when we have created. Now let me execute, and here is the age group, and this is how your age the age has been categorized into the groups. So 25 comes under 20 to 29, 30 comes under 20 to 29, 22 comes under 20 to 29, whereas 35 comes under 30 to 39, 28 comes under 20 to 29 again. So that's how, if you want to see, I'll increase this 22 to 45, sorry, 56, and nope, that's it, yep, that's it. So all three, 20 to 29 group, and 40 to 49 group, and 30 to 39 group. Okay, let's take a similar example, but this time it's a real world data set. So let me say players is equals to pandas dot read csv, and I'm gonna go with the soccer players data one, and players, yep, this is what is our data. Now, so what I'm going to target is I'm going to target weight in kgs. So if weight is between, okay, but before that let me check here, players weight. So I'll go with the min, sorry, I'm going to go with weight. Yep, min is 30. I'll go for the max. It's 218. Okay. Now let's convert them. So let's make it. So D, okay. So the minimum is 30 and maximum is to 218. Based on that, I will convert that into three categories or four categories: lean, then normal, fat, and obese. Okay, let's do that. So let me take the same bin here. So let me create my pins. Starts with 30 till 50 it's lean, till 80 it is normal, and till 120 it's fat, and till 218 it's obese. So labels I'll put as lean player, and then I have normal player, fat player, and obese. So you see that you have n bins and n minus 1 labels. That's it. It's ready. So now let's add a new column. Oh, no, here we don't need to add a new column. We'll just put it separately. Okay, so that we can view it. So let's create a series, panda series. So players, I'm gonna name it as weight groups is equals to players dot cut pandas data. We'll use cut method here. So cut method. So the first one is players. So which variable? It's a weight. This one I want to group it, the weight one. So bins as usual. Bins is equals to bins. Yeah. And labels is equals to labels. Rest all done. Let me execute. So remove these things and call weight groups, and that's it. Ready. Your weight groups is ready. And if you want to see the unique, it's only three. That's normal, lean, fat, obese. That's how we have converted. And here is that. That's it. Now if you want to add it into the table, just do the same thing. Players and weight groups is equals to, sorry, just a minute. And here is your data. So weight groups has been added. If you see that 69 is normal, 64 is normal, 88 is fat, and 63 is normal, 84 is fat, and it goes on. It goes on. So that's your data. So now this is how we categorize, and this is how we use uh, cut a cut method to categorize our data. So now let's categorize data using qcut function. We'll do it using qcut function. So let's categorize data using qcut. Okay, so this time let's create a simple data frame. Let's create a simple data frame. df1 is equals to pandas dot data frame, and income list of, I'll take the same values. Income, this one, to complete the sequence I'm gonna take. Why to make things complicated? Yep. Yeah, let's just waiting for this to respond back. Yep, done. Okay, so our data frame is ready. Now define quantiles and labels for categorization. This is another way. So what is quantile we will see later, but for now you just focus on how to categorize, nothing else. So define quantiles and labels for categorization. Quantiles, so 0, 0.25, 0.5, 0.75, and finally 1. These are our quantiles. So labels, obviously n minus 1. Labels is equals to, I'll say, quantile 1, that's q1, and quantile 2, q2. Let's do one thing. Let's copy paste it. Okay, let me change the quantiles now. 4, 3, 2. That's it. So labels are ready, quantiles are ready. So now that's a quantile cut. This is a quantile cut method. So add a new column, that's income quantile, to data frame based on the income column. Okay, so df1 of income quartile income quantile is equals to pd dot q cut of so df, so income, this is what has to be categorized. This has to be categorized, and q is equals to quantiles, that's what we have defined there, and then labels is equals to labels. That's it. It's time to print and see the data. So the issue here is pass false for duplicate. Labels must be unique if ordered true. Okay, that's okay. Yep, here it is. So income quantile, 50,000 is quantile 1, 60,000 is 2, 55 is 1, again 4, 3, all were categorized. And let's look into the one more example and we will wrap this up. But this time for the categorization, we'll use a map object. We call it as a, this object is also known as generative, or no, we also call it as a iterator in Python. If you have enough knowledge in Python, you would have got it. Okay, categorizing data using map function. Map function. So let's take a data frame again, df. This time we'll take the gender data frame. So pd dot data frame, and inside that I'm going to create okay, a dictionary, a key value pair, and a list of male and then female, and repeat it. Let me just copy paste it simply. That's it. Our data frame is ready. Now let's define mapping of values to categories. So gender map is equals to, so whenever you find male, just say M. This is called a mapping. And whenever you find female, this all whatever we have done so far using a cut method or qcut method or using a map function, these functions will be useful when you are doing exploratory data analysis in your data science projects. And it's F. That's it. Your gender map is ready. Now it's time to map. So let's add a new column called gender short to data frame by mapping values from gender map. Gender map and gender. Okay, let me do that. Gender. From mapping gender short, okay. Now df gender underscore short is equal to, so gender, I want to represent the gender as a in short notation. So that's what I'm gonna do. So df of gender, so dot use map. And how do you want to map? You want to map with gender map variable name. That's it. I think it's done. Now it's time to print df. And here is that. This is your gender mapped, and male, female, male, female, male, female has been mapped with the short notation male M, female F, male M, female F, male M. So that's how we use. So these are some examples of data categorization using pandas in Python. So we can use various functions and methods provided by pandas library to categorize data based on our specific requirements.